Framework is backed by deep integration into a new developer toolchain with ahead-of-time compilation, dedicated Core AI instruments, and a powerful visual debugger to trace tensor values directly back to your original Python source code. And is engineered to scale with your available compute.
So you can run a compact vision model in your iPhone app for real-time camera queries, or deploy a multi-billion parameter LLM in a Mac app right at your desk to power an agentic assistant for complex multi-step workflows. Whatever the device, whatever the model, it all runs on device with zero server dependencies and zero token costs. Core AI is optimized for performance on Apple Silicon and powers Apple Intelligence experiences across the system, including Siri.
And this year, Apple Intelligence offers even more opportunities for developers. Over to Lori.
Apple Intelligence draws on personal context from across apps, understands what's on screen, and can take actions to get things done. And now you can integrate with its capabilities through the App Intents framework. It's how our platforms understand what your apps can do. With it, you can make your app's content easier to find and its capabilities easier to use through the action button, shortcuts, widgets, and in Siri AI. App Intents schemas make integration with Siri's capabilities easy. Schemas are recognizable structures that Siri understands deeply, built on years of language model training. We provide entity schemas for describing the content and concepts your app works with, and intent schemas for describing the actions it can perform. Entity schemas enable personal context understanding. By contributing your app's content to the Spotlight Semantic Index, you can help your users find information from your app quickly and easily with attribution back to your app. The indexing keys for important content properties are built right in, which means more understanding from less code. Siri's understanding of intent schemas means people can make requests naturally. They don't need to learn specific phrases, and you don't have to define them in your code. Schemas cover common app categories like task management, photo editing, and communication, and include a whole set of system-supported actions. Just adopt the relevant intent schemas for the actions your app can perform to make them available to your users. And because these schemas are system-defined, they'll benefit from future updates. That means as Siri's language understanding evolves, or as we add new support for languages or regional dialects, your intents will work there too, without any changes to your code. Combining these capabilities with the new View Annotations API will let your users reference and take action on the content in your app when it's on screen. So your users can interact with your app conversationally, saying what feels natural to them, not commands they have to memorize. Now, I'm going to show you how we've made our Origami app work with Siri. I already have some entities and intents that describe my app's content and actions, and the entities conform to the index entity protocol, so they can be indexed into Spotlight. By also conforming to an entity schema, Siri will be able to discover and reason over my app's content. I'll make sure my message, contact, and conversation entities all conform to the relevant entity schemas by using the app entity macro. I'm indexing these entities into Spotlight when my app finishes launching to make sure everything's in sync. I've rebuilt to get the latest changes, and now let's see what I can do, even when I'm not in the app. Hey Siri, who's coming to Origami Night?
Based on your messages in Origami, it looks like Kevin, Mary Beth, Rachel, and Richard are discussing Origami Night.
What's Richard bringing?
Richard mentioned he is thinking of bringing pizza.
Awesome. But now I want to follow up, which means I need to act on this information. I can make the content Siri found actionable by conforming an intent to the send message schema. This time I'm using the app intent macro, since this is an action rather than content. I'll build and run again, and now I can say, Siri, text Richard, can you make one of the pizzas vegetarian?
From Origami. Ready to send it?
Yes.
It's sent.
Great, message sent. I'd also like to let people reference what's on screen in my app just by saying the second message or this photo. The new View Annotations API lets me associate my views with entities, which can then be passed to my app's intents, making them actionable. My message list view contains all the individual messages in a conversation. I can use a new view modifier to map each message row to its respective message entity. Let's try it out. Hey Siri, send this photo to Kevin and say, Rachel got us some paper to practice our folds. What color would you like?
From Origami. Ready to send it?
Yes.
It's sent.
And Siri sends the photo with my message. By combining personal context, common app actions, and on-screen awareness, your app can become part of the intelligent fabric of the system. Through Siri, users can access it through natural language, discover it through semantic search, and integrate it into their daily workflows. Now, back to Josh.
This is our vision for an intelligent platform. Rich, native experiences, and intelligent, natural language interfaces working together. As app developers, this represents an incredible opportunity. You can enhance your app's experiences through natural language with Siri. Build powerful AI features with the Foundation Models framework, and even run your own models on device with Core AI. If you're using a custom model to power a feature within your app, Core AI is the right technology to use. Your models will perform efficiently across all devices, and it's built into the platform, so your apps always benefit from the latest fixes and enhancements. And if you're an enthusiast who is experimenting with, training, researching, or fine-tuning generative models, or if you're running a local inference server, our array framework, MLX, makes it easy to explore cutting-edge innovations and technologies. It now supports Metal 4, GPU neural accelerators, and it can even scale training across multiple Macs with RDMA over Thunderbolt. It's all open source, and it's faster than ever. The breadth of capabilities offered by Apple Intelligence and powered by Apple Silicon makes Apple's platforms the best place to build and deliver the next generation of intelligence-enhanced apps and games. Now, let's take a look a level deeper at what makes all of this possible. The systems your apps depend on, from the frameworks you call to the processes that schedule your work, manage your memory, and render your UI. We took an especially close look at the performance and quality of these foundations, and you'll see a multitude of platform improvements in this year's releases. When you rebuild with the new SDK, your apps will launch faster and feel more responsive. You'll see refinements and platform improvements across frameworks, media, search, and accessibility, enhancements to Swift and SwiftUI, and a lot more, especially around design. Last year, the new design with Liquid Glass brought a unified design language built for a world where your experience moves across devices. The new design is making apps more expressive and delightful while staying instantly familiar to users. It looks great in apps like Tide Guide, where subtle, interactive highlights respond as users scroll through Tide data and charts. And Sketch Pro, where translucent brush panels and controls let artwork show through, even while you switch between tools. Throughout the last year, we've been refining the design, and that journey continues with a new set of design updates in the 27 releases. Apps that have already adopted Liquid Glass benefit from many of these improvements automatically. To tell you more, here's Cindy.
In this year's releases, you'll see updates to the foundations of how Liquid Glass is built, refinements to the new design that improve consistency, and new ways for iOS apps to adapt across devices and screen sizes. Let's review the changes you'll see in your apps. To maintain exceptional readability, we tuned Liquid Glass so it more effectively diffuses complex content behind it. And to establish more depth and separation, we also introduced a darkened edge along with brighter specular highlights. We also made it more personalizable, with a new slider in settings to adjust Liquid Glass anywhere from ultra clear to fully tinted, allowing users to choose the look that works best for them. Apps already using Liquid Glass get these improvements automatically when they run on this year's releases without even needing to recompile. Liquid Glass seamlessly adapts to a variety of accessibility settings users may choose, such as reducing transparency or increasing contrast. And now, macOS 27 also supports the Show Borders environment value, just like iOS. So you can adapt your macOS app's custom controls for this setting as well. Sidebars expand to the edges on Mac and iPad, providing clearer structure while still reflecting content from your app and the wallpaper. And icons in the sidebar regain their color using your app's accent color, giving your app more personality and making it more clear which window is key. List and label APIs provide these updates automatically and support customizing the tint per item. And every window on macOS now also has the same tighter corner radius, ensuring greater consistency across all apps. When content scrolls under floating bars, a uniform toolbar appears across the top and keeps the text legible while improving contrast. This effect is applied automatically for standard toolbars and can be customized using the existing Scroll Edge Effect APIs. We also thought about how icons and menus can be used intentionally to call attention to the most important actions, both on macOS and iPadOS. While icons are hidden by default, there's an API to show icons for key app actions. We're also updating how Liquid Glass shows up in icons, making them sharper and more defined. This updated rendering applies to all app icons, and we've introduced new features such as refraction that can be selectively used for added character. And with Icon Composer, you can now design your icons out of multiple layers of Liquid Glass. It's been updated with new annotation features to add refraction or dial in Liquid Glass content effects. And it provides an interactive preview of how your icon will look on earlier releases. Together, these updates culminate in a more focused and approachable experience across your apps and across platforms. Next, let's talk about app adaptability. iOS apps show up in more places than ever, on iPad as an iPhone app, or on Mac through iPhone mirroring. When your iOS app shows up in these other contexts with larger displays, users want to be able to take advantage of the extra space to see more information. So this year, we're introducing support to resize iOS apps in iPhone mirroring and on iPad. Let's see how this works with the Origami app. Once you rebuild with the latest SDK, your app is automatically opted into resizability. Since Origami is a SwiftUI app, it's already taking advantage of scene lifecycle and standard framework support for basic resizability. If you're already using SwiftUI, auto layout, or responding to size class changes, you are well on your way to supporting full resizability. If you have custom views, you'll want to update them to using auto layout and trait collections for layout decisions. Using the new resizable iOS simulator and previews, you can test across a variety of screen sizes right in Xcode, so you'll see exactly how your layout performs. And we're providing a skill for coding agents that will help you find and fix common resizability issues. Now, instead of designing for specific devices and orientations, you're designing for a dynamic range of sizes and aspect ratios. To provide the best experience when using iPhone mirroring, update your app to be able to adapt and support any size. Resizable simulator, previews, and iPhone mirroring all make it easy to ensure your app is as dynamic and flexible as possible. Next, let's talk about SwiftUI. Here's Frank.
SwiftUI is the best way to build apps for any Apple device. We designed SwiftUI to capture everything we know about building great apps on our platforms. It gracefully handles the complexities of layout, animation, and platform integration so you can focus on what makes your app yours. And as new capabilities like Liquid Glass are added, apps get these features easily because they're designed with SwiftUI in mind. New apps like The Goat are built with SwiftUI because they want to feel truly at home on Apple platforms. The Goat is a game development environment that brings the open source Godot engine to Apple devices. It started on iPad, expanded to iPhone, and when the time came to bring it to Mac, it felt completely natural. And apps that previously used cross-platform or web technologies like Notion are migrating their user interface to SwiftUI because they want a level of performance and UI consistency that other technologies can't deliver. With powerful agentic coding tools, porting code to Swift has never been easier. Of course, we reach for SwiftUI ourselves whenever we build apps. For example, SwiftUI made it easy to build a new Siri app by enabling us to share code across all our platforms, and Creator Studio apps like Logic Pro build new features with SwiftUI for high performance and cross-platform support. Since we rely on SwiftUI ourselves, every improvement we make for our own apps becomes an improvement for your apps too. And this is a big year for SwiftUI, with richer interactions that help you write less custom code with speed, making your apps much faster. And finally, with new capabilities for your apps. Let's start with interactions. This year, SwiftUI brings more dynamic interactions to your app like reorderable containers, which makes it super easy to add drag to reorder to any container. Building a great reordering experience outside of lists, like with this grid in the Origami app, used to require a lot of code. Now, it is just as simple as adding reorderable to your for each and reorder container to the parent. And just like that, I can customize the order of my Origami models. SwiftUI handles the lift and the drop animations, and it works with any container like grids and stacks. Now, for Origami models I feel a little less proud of, SwiftUI now supports swipe actions inside any container as well. I can delete a custom row with a swipe by adding the existing swipe actions modifier to my row and swipe actions container to the scrollable container. This provides great flexibility for quick actions on my custom row. Finally, text selection got more flexible too. On iOS, it gains the same full fidelity selection already found in text field and text editor. And on macOS, it now supports custom text renderers, text vibrancy, and vertical text. Next, let's take a look at speed. This is always a priority for us, but even more so this year. And you will see many improvements without any changes on your end. To start, we've been gradually unifying the architectures of SwiftUI, AppKit, and UIKit. And this year, they share a common foundation across many controls. So wherever your app is running, they can benefit from the same underlying improvements. For example, menu pickers on macOS are now better equipped to smoothly handle large lists of items. And in nested stack layouts, whereas SwiftUI used to measure each child multiple times to resolve their flexibility, it now short-circuits computations where they're not needed, meaning layouts now resize up to twice as fast. And nothing saves performance like avoiding unnecessary work. SwiftUI now only initializes state objects when they're first loaded. Previously, a new temporary instance of the state object would get created every time the view is reinitialized. You get this improvement for free because state is now lazy under the hood and was converted from a dynamic property to a macro. And when it comes to loading images, async image avoids redundancies as well. It now caches its contents automatically using standard HTTP caching. So images are downloaded once and only refreshed when needed. Finally, let's talk about new capabilities, starting with toolbars. With the new resizability features, optimizing your app for a dynamic range of sizes and aspect ratios is more important than ever. And toolbars are central to that experience. This year, SwiftUI gives you final control over how toolbar items adapt to space. Use a new visibility priority modifier to mark your most important items high, and SwiftUI keeps them visible longer as space shrinks. Less prominent actions, like archive or delete, can be added to the new toolbar overflow menu container, which groups them in an overflow menu. And finally, the new top bar pinned trailing placement anchors items to the trailing edge, no matter how the toolbar reflows. Now, when I resize the window, the toolbar stays organized exactly how I want. Important buttons stay visible, deprioritized ones are in the overflow menu, and share is always pinned to the trailing edge. Tabs can also be distinguished with the new prominent tab row, pinning the tab to the trailing edge of the screen. SwiftUI also opens up new ground for document-based apps with a new document infrastructure that provides a ton of functionality out of the box, like first-class URL access for fully customizable reading and writing to disk, the kind that powers apps like Xcode or Pages. For example, with direct access to the file URL, you now have the flexibility to read just the parts of a file you need and write only the pieces that changed, not the entire file. You can also observe and update document attributes using the provided observable configuration. The new document API integrates deeply with modern Swift, with support for observation, Swift concurrency, and so much more. Lastly, here's something pretty awesome. The Spatial Preview Framework gives Mac apps new ways to extend in space around users wearing Apple Vision Pro. When you adopt this new API in your app, a 3D model can become spatial when you stream to Apple Vision Pro, allowing your users to preview, edit, and share objects and models in real time. Beyond those we've mentioned already, there are many other new improvements, including better type checking performance with content builders, a new alert binding API, and supports for crossfit transitions. Together, these platform improvements bring more speed, richer interactions, and powerful new capabilities to SwiftUI that you can take advantage of. Now, let's take a look at Swift itself. Here's Holly.
Swift is designed to be the language you reach for at every layer of the stack. Whether you're building full-featured mobile apps, internet-scale services, or embedded firmware, Swift helps you write code that's fast, expressive, and safe. Swift's performance, depth, and unmatched interoperability make it the natural successor to C and C++ for low-level systems and server programming. And its approachability and expressiveness make it ideal for higher-level development, like apps and frameworks. We think Swift is the only language with this breadth. That's what makes Swift a language you can keep reaching for as your stack grows, including outside Apple platforms, where the tools for development on Linux, Windows, Android, and the web are available on swift.org. Many of you are extending your use of Swift to additional platforms and the server, so you can reuse code and benefit from Swift's high performance across your entire stack. Like Flighty, which uses Swift in their services to share the code that tracks airport visits between the app and backend. Or GoodNotes, which uses Swift for WebAssembly to bring the app to the web, Chrome OS, Android, and Windows, reusing over 100,000 lines of code. Or Framio, which uses Swift Java interoperability to share Swift libraries between the iOS app and the photo frame software written in Java. Interoperability means you can bring Swift into C, C++, and Java systems you already have, so you can get Swift's benefits at every layer without a rewrite. At Apple, we've been building with Swift at every layer of our own stack. Foundation paved the way for Objective-C frameworks to move to native Swift under the hood. AppKit and UIKit have followed suit by using Swift and SwiftUI extensively in their implementation. WebKit, the open-source web engine that powers Safari, is a large and security-critical C++ codebase. Using Swift's safe C++ interoperability, WebKit is replacing core components with Swift versions incrementally. In the networking stack, the quick transport layer was rewritten in Swift. Later this month, the project will be open-sourced and available for cross-platform use through Swift Neo integration. You can follow along or get involved through the vibrant open-source community on swift.org. Further down the stack, more security and performance-critical systems moved to Swift this year. The TrueType font rendering engine replaced decades of hand-optimized C with Swift code that's not only memory-safe, but also faster. At the lowest level, we've written hundreds of thousands of lines of Swift code across bare metal firmware, coprocessors, and drivers. For the 27 releases, we've started writing parts of the core operating system kernel in Swift. As Swift becomes more capable in these domains, we're staying true to one of Swift's most important design goals. It's fun. It's natural to write and iterate on your ideas in Swift, and the compiler is there to catch mistakes along the way. The latest updates are focused on improving your workflow, so you can focus on the fun part, writing great code with confidence. Swift 6.4 is here, built to make everyday tasks feel effortless. I'll show you just a few examples. When your codebase is undergoing a migration or incremental adoption of new features, sometimes it's not realistic to address all compiler warnings across your project at once. You can now suppress warnings in specific parts of your code, and you can promote warnings to errors in places where you want strict enforcement. Availability attributes can get long and repetitive when you're writing code for multiple Apple platforms. Now, instead of listing out every Apple platform with the same version number, you can simply write any Apple OS. The limitation on async calls in a defer block is gone, and awaiting inside a defer just works. No matter what you're building, Swift's compiler diagnostics are a daily companion, helping you catch mistakes early and guiding you toward correct code. If you spent time writing Swift code, you've probably encountered this error message. The compiler is unable to type check this expression in reasonable time. This can happen in complex operator expressions, closures, or in deeply nested SwiftUI view bodies. This is frustrating, and we've made it a lot better. In many common cases, code that hit this fallback error will now either compile successfully or give you a more actionable error to work with. We know this area is important for a smooth workflow, and we're continuing to invest in it. Swift 6.4 makes you more productive in day-to-day code, and it brings that same care to the more specialized corners of your project. There's never been a better time to go full stack with Swift. Now, back to Josh.
So those are the platform improvements in this year's releases. Now, to move ahead, sometimes we have to leave something behind. As we said last year, macOS Tahoe was the final release to support Intel Macs. The transition of macOS to Apple Silicon is now complete, enabling us to focus on a single architecture across the entire ecosystem. This can benefit your apps as well. You can now ship Apple Silicon-only binaries on the Mac App Store, reducing your app's download size and letting you focus your testing on a single architecture. And with all the refinements to the new design with Liquid Glass, it's time to complete your migration there too. We'll be removing support for opting to use the old design. So once your app is recompiled with Xcode 27, it will automatically begin to use the new design with Liquid Glass. With so many improvements across the system, your apps and games will look and feel better than ever on this year's releases. Now, let's turn to your productivity and the tools you use to build with and for our platforms. Intelligence is deeply transforming how you write code, add new features, and build apps. Last year, we brought AI coding assistance to Xcode, and so many of you embraced it immediately. It's helping you write code faster and adopt new APIs more easily. This space moves really fast, so we've picked up the pace of our releases, delivering new Xcode capabilities to you faster than ever before. Earlier this year, we brought coding agents to Xcode, along with tools allowing agents to grab a preview, search documentation, and more, powered by the Model Context Protocol. With MCP, Xcode also connects to the tools you already use, from design apps like Figma to services like GitHub. And Xcode includes a built-in integration for agents from Anthropic, OpenAI, and now Google. Today, Xcode adds support for Agent Client Protocol, so you can bring any compatible agent into Xcode. ACP support and Gemini integration are shipping in an update to Xcode 26 available today. And there's more coming in Xcode 27. Here's Ken.
From the first line of code to the App Store, Xcode is where you build the best apps for Apple platforms. Millions of you live in it for writing and debugging your code with coding agents right alongside. Designing interfaces in SwiftUI and previewing them in real time. Testing across devices and simulators to catch issues before your users do. And profiling performance with instruments, keeping your apps fast, responsive, and efficient. This year, Xcode has two big stories. The first is intelligence, and we have a lot to talk about in a minute. The second is the daily experience, how Xcode feels to use. Now, just like you, we spend hours in Xcode every day. We build all our operating systems and apps with it. In fact, we build Xcode with Xcode. So it needs to feel like home while being fast, fun, and personal. Now, we've heard your feedback and improved Xcode across the board. It's faster at loading projects. We fixed top crashes and spins. Debug sessions are more reliable, with faster expression evaluation, and a console that can handle more intensive logging without hitching. Xcode 27 is 30% smaller. Now, Apple Silicon only, with agents, documentation, and other components downloading in the background so you're always up to date. Now, let's take a look at the experience. First, your Xcode settings are now automatically saved to iCloud. When I'm setting up a new Mac like this, Xcode offers to import them. I'll pull in the settings from my iMac. I can sign in with my Apple ID. Xcode fills in my Git config too. And just like that, I'm ready to code with my new Mac. Now, let's create a new project. Watch this. I'll select New Project, then App, and boom, I'm in the editor. No file name, no bundle ID, no setup. Now, of course, I can specify all those things later when I'm ready. This is great for exploring an idea, a new API, or prototyping a view. All right, now I'll open the origami project. Xcode 27 looks beautiful with the design refinements of macOS 27. Crisp and clean. Let's customize it. In Xcode 27, you can make the toolbar your own. It's easy to rearrange things, so I can add what I need and remove what I don't. The activity view is now tucked neatly into the document title over here, so there's even more room for the things I want. The navigation buttons, canvas toggle, editor splits, they're all right up here on the toolbar. Now I'll add a shortcut to quickly create a new coding assistant conversation, and that'll be useful a little bit later. Next, and super fun, themes. Color now flows throughout the entire app, not just the editor. You can personalize everything, from the background to syntax colors, and dial in that perfect shade of purple for your keywords. And Xcode 27 comes with gorgeous new choices. Let me show you a few of my favorites. Emerald, that feels fresh. You can almost smell it. How about something with a little bit more energy? Neon Noir, electric, love it. Light or dark, every theme supports both. Here's Coral Reef. I feel relaxed already. When I'm working on multiple projects at the same time, I can set a different theme for each. Makes it super easy to tell them apart at a glance. All right, let's get back to work. Next, Xcode Cloud, which gives you continuous integration and delivery built right into Xcode. Now I'll set up my origami project to use it. I'll click Get Started, grant access to my repository, and that's it. I can kick off my first cloud build. No App Store Connect setup needed. And Xcode Cloud builds are up to twice as fast, now supporting Apple Vision Pro and apps using Metal on Apple Silicon. Next, previews. They are the best way to iterate on UI, and the easiest way to see how your views look across variants, like accessibility sizes, orientations, and localizations. And now you can see variations for any property. I'll open this view here that shows a craft node. It renders differently based on the craft state enum, which has 4 different values. Now I can pass that enum to the preview, and just like that, I get a grid showing all the states of my UI, all 4 in one glance. Next, another one I'm excited about. When testing your app, you use real hardware to evaluate performance, use sensors, and test real-world conditions. And you use simulators to cover older OSs and devices that you don't have. Xcode 27 brings both together in the new Device Hub. It replaces Simulator, and it does a whole lot more too. Let me show you. When I first run my app, the window looks like the simulator I know. I can easily rotate, grab a screenshot, and jump back to the home screen, just like I'm used to. When I extend the view, I can now change device properties and test how my app responds to different system settings, like switching to dark mode, increasing the font size, and more. We rebuilt the experience from the ground up for the highest fidelity possible. So I can pitch to zoom, use 2-finger scrolling, and like in previews, I can dynamically resize the simulator to see how my iOS app handles different sizes. I can also manage and interact with physical devices from the same place, like this iPhone here on my desk. I'll launch the Origami app right here from my Mac, and I can interact with it. All the convenience of the simulator with the fidelity of real hardware in a single place. That is a quick look at the experience in Xcode 27. And beyond the experience, the biggest changes this year, the ones that will truly accelerate you, are in intelligence. Kevin, over to you.
What a great time to be a developer. Intelligence is transforming how you build apps. Agentic coding, together with Apple platforms, frameworks, and tools, helps you bring ideas to life. Xcode 27 takes the next big step in agentic coding, leveraging the full power of the best models and agents directly into Xcode. Agents are woven into every layer of the Xcode experience, from the way you interact with them to a set of tools that help you get the best results. Tools like understanding your project, searching documentation, building, and testing. And Xcode 27 helps you even more, with new tools like rendering previews with variants, interacting with the simulator, localizing your app, debugging, and more. And this goes beyond tools. When using agents in Xcode, every answer is grounded in Swift, SwiftUI, and Apple frameworks. That's why, when building for Apple platforms, Xcode is the best place to code with agents. Let me show you what this looks like across every stage of app development, from starting with an idea, to implementing and validating it, to improving it, like adding new languages or fixing issues. First, I'm going to add something fun to the Origami app. My daughter, she loves making origami with me. I want to surprise her with a feature that makes up a little choose-your-own-adventure story about the characters that we make together. I'll start with a new conversation with the agent. I'll create one here from the toolbar. It opens right in the editor, just like any other file. Here's what I want to build. In my origami project, I want a button that generates a choose-your-own-adventure story for my daughter. That alone would get me good results, but I had something a little more specific in mind, so I'll add some more details. She'll start by picking some options, like the setting and an item to use in the story. The app will generate the first page, and then let her pick what comes next. I want to use the latest foundation model APIs and present it with beautiful typography. When using a coding agent, the best results come from collaborating on the implementation and design first, before any code is written. So I'll add /plan to the prompt. And I'm going to ask for a diagram while I'm at it. I find it easier to review the plan that way. Let's get this started. The agent is exploring my project using Xcode tools to help it efficiently understand my codebase, its architecture and patterns, to find the best way to build the feature. And it's asking some clarifying questions. Do I want to persist it? Yes. And how many options for the next part of the story? 2 to 3 is good. And the agent continues to create the plan. Let's skip forward in time. My plan is now ready, and it shows right next to the conversation in beautifully rendered Markdown. It's very easy to review. And I can also refine it. Here, the current implementation has a fixed set of settings and items to choose. I'd love if she could add her own. I'll add it as a comment. And now the plan looks good. Let's kick it off. Now Xcode and the agent work together to implement the plan. Xcode shows everything that's changing, like code and previews. As it runs, I can refine the implementation. Like here, I'm going to add a fun image filter to the story's hero image. It looks like Xcode is done building my feature. There's a lot of code, and the previews look great. Let's just run it. I'll open an origami project, tap the new toolbar icon, and just like we asked, page 1 offers an item and a setting. I'll pick a forest and a wand, and oh, look, there's the button if I wanted to add my own. And here's the first page of the story with that gorgeous hero image. My daughter's gonna love this. What was just an idea a couple minutes ago is now something I can run in my app. This is amazing. Now, building a feature is more than writing code. It's also making sure it does what it's supposed to do. Xcode 27 can help you with that too, with new tools for agents to check their work. For example, agents can validate the logic of your app by running tests, try ideas in isolation using playgrounds, like experimenting with APIs, and check visual changes with previews in light and dark mode, different orientations, text sizes, or localizations. And now, agents can interact with your app in the simulator. Let me show you. I want to test different combinations of settings, items, even customized ones. Xcode launches Origami in Device Hub and starts testing those for me. The agent can tap, swipe, and type. When it's done, I get a summary of the tests, and I can see all the screenshots it created along the way. And just like that, the Origami app has a new story feature, designed, built, and tested end-to-end. Next, let's see how we can use agentic coding to improve our app. Agents in Xcode can help with all kinds of engineering tasks, like adopting new APIs, making your app more accessible, and more. Let's localize our Origami app. I'll start with French. Xcode automatically adds a new language to the strings catalog, then works with the agents to translate strings across the entire project. This is more than a word-for-word translation. Xcode looks at each string in its context, the surrounding code, UI, the action, to find the best translation. And when it's done, I can see all the translations here in the string catalog. Let's build and run. My app is now localized. Fantastique. Building a great app also means responding to the feedback and data from your users. The organizer already gives you insights into how your app is doing in the real world. Crashes, hangs, performance metrics, anonymized and aggregated. Now, you can use agents to help you find issues that matter most and fix them. I'll ask Xcode to pull up the top crashes from the latest release. I get a list of crashes ranked by how often they happen. Oh, that first one is from an update I pushed last week. Let's fix it. Xcode looks at the symbolicated crash log, figures out where in my project this happens, identifies the issue, reproduces the crash, makes the fix, and then validates it. And just like that, our issue is fixed. That's agents at work with Xcode across every stage of your development, planning, building, and improving. You'll be amazed when you see Xcode and agents bring your ideas to life. Finally, let's talk about what makes all of this possible. Xcode 27 ships with the expertise of Apple's engineers and designers built right in as a corpus of skills, documentation, and MCP tools. Think of them as specialists. A SwiftUI specialist that knows how to structure your view and data flow. An accessibility specialist that knows what makes an interface work for everyone. Specialists for universal sizing, testing, and performance. In fact, so much of what we've seen to this point is powered by one of these specialists. And you can bring your own. Xcode integrates all of them in the same way, plugins. It's a format used by many agents and widely adopted by the community. It's amazing to see how many of these you have already been building and sharing. A plugin can contain skills, just markdown files that teach the agent new tasks. It can contain tools using the Model Context Protocol. And we've added one new capability to plugins. With the Agent Client Protocol, a plugin can bring an agent of your choice. Installing one is easy. You can use the command line or paste a Git URL right into Xcode. And partners like Figma and GitHub make it even easier to set up with just one click. And then I can put it all together. I can tell Xcode to implement a Figma design in SwiftUI, refine it for different variants, make it resizable using a skill, and post a PR to GitHub. How cool is that? That's agentic coding in Xcode 27, from an idea to an app at every step. Built for how you create, refine, and ship, and reach your users wherever they are. We can't wait to see what great things you make next. Back to you, Josh.
It's a huge year for Xcode, and for many of our other developer tools as well, like the all-new Reality Composer Pro 3, which has been completely rebuilt for crafting production-ready 3D experiences using RealityKit. It brings support for character animations, more realistic lighting, and live previews that let you see the results of your edits as you make them using Mac Virtual Display. And there's even more for game developers in this year's releases, including a major update to Game Porting Toolkit, which dramatically cuts the time it takes to bring games to Apple platforms by adding AI skills for coding agents. And new Metal command line tools give agents direct control during development and debugging, bringing best practices for game development on Apple platforms to every step of your porting journey. So that's developer productivity. Across the 2027 releases, there are so many new capabilities to build on, like the App Intents framework, which lets you connect your app to Apple Intelligence, and the Foundation Models framework and Core AI, which enable you to bring powerful generative intelligence features directly into your apps. There are platform improvements across design, Swift, and Swift UI that make your apps faster, more flexible, and easier to build. And Xcode has even more expansive support for agentic coding. And we've only just scratched the surface. There are over 100 sessions to dive deep into everything we've covered today, including Apple Intelligence, Xcode 27, design, and more. All these sessions are available on the Apple Developer app, the website, YouTube, and new this year, on Bilibili. And there's so much more happening online throughout the week. Sign up for group labs, online panels, and Q&A sessions with Apple engineers and designers. And connect with us on the Apple Developer Forums to ask questions and follow the conversation about the latest tools and technologies. And the opportunities to connect extend well beyond this week. You can meet with Apple around the world and online in hands-on workshops, labs, and events to learn and connect as a community throughout the year. We love when we can meet you in person, and there are many opportunities to do that in our developer centers, located in Cupertino, Shanghai, Singapore, and Bengaluru. And we're excited to announce the opening of our 5th this fall in Berlin, home to one of Europe's most vibrant developer and designer communities. We can't wait to see you there, or in one of our events online, whether this is your first WWDC or your 25th. Thank you. Your work inspires and drives us. We use the apps and play the games that you all build. So our greatest hope is that everything we talked about today will enable your next great idea to come to life. We can't wait to see what you do next. Enjoy WWDC.
Up there, so definitely start there. And if you feel like it's lacking some of the details, there's always the community resources that can walk you through.
And I actually want to throw back. Hello, and welcome to the SwiftUI for Beginners Group Lab. My name's Kurt, and I'm part of the worldwide developer relations team here at Apple. I'm joined by engineers and leaders from the UI Frameworks team, Gabriel, Jeff, Sam, Seema, and Trevor. In addition to us on screen, there's a team behind the scenes helping with the triage of all your inbound questions. We're excited to answer your questions today about getting started with SwiftUI. If you have code-specific questions or we can't get to your question today, we'll continue the conversation on the developer forums at developer.apple.com/forums. If you have a bug or feature request, please go to feedbackassistant.apple.com. We'll focus on questions today that will help the broadest audience. Whether you're new to programming, new to Apple's platforms, or just new to SwiftUI, we're looking forward to answering your questions. We'll start with a quick overview of SwiftUI, then dig into Q&A. Seema, get us started.
SwiftUI is Apple's declarative user interface framework, used to build apps across all of Apple's platforms. When you are building a new app or a new feature, SwiftUI is the right tool to use. There are a few reasons for this. SwiftUI comes with a wide range of features. These enable your apps to take advantage of the devices they run on, feel native on Apple's platforms, and add rich interactivity. And adding those features requires less code, enabling you to move from prototype to production faster, and empowering you to focus on what makes your app unique. SwiftUI embraces incremental adoption, so you can use it exactly where you need it. There is no expectation that an entire app needs to be SwiftUI to be able to take advantage of it. These qualities make it easy for anyone to learn how to build an app using SwiftUI. Views are the basic building blocks of user interfaces and are important to everything you do in SwiftUI. Every pixel you see on screen is in some way defined by a view.
Views are expressed declaratively. You describe what view you want in your user interface, and SwiftUI produces the result. This code creates a horizontal stack that consists of a label, which is a combination of an icon and a title, a spacer, and a text at the end. This same declarative syntax applies to other containers, such as scrollable lists. This list is given a collection of pets and creates a series of rows using the properties of each pet. At no point do we need to describe the actions necessary to produce this interface, such as adding or removing from the list. This is because SwiftUI views are descriptions of what the current state of the UI should be. They are not long-lived object instances that receive imperative commands over time. As such, SwiftUI views are value types, defined using structures instead of classes. Composition is used throughout SwiftUI and is an essential part of every user interface. Rearranging and experimenting with container views is effortless. The code itself resembles the hierarchy of views that it creates. This horizontal stack contains 3 views: an image, vertical stack, and spacer. And the vertical stack contains 2 views of its own, the label and text. View hierarchies can be encapsulated into custom views and view modifiers, enabling the same compositional features and quick iteration. These custom views can have inputs that change how their body is constructed. This view has a property for the pet that this row represents, which can be used to change the contents of the contained views. This lets the same view display information about Whiskers, as well as Rufus and Bubbles. And custom views can be used like any other view. Here, they're used in a list to create fresh rows for each pet. But apps aren't just static screens, they're dynamic, changing with time and interaction. Of course, SwiftUI has you covered there too.
Views in SwiftUI are state-driven. You declare what state they depend on, and SwiftUI does the work to keep your views in sync with that data. When your view's state changes over time, SwiftUI automatically keeps the UI that depends on it up to date, while avoiding reevaluating things that won't change, eliminating both boilerplate and update bugs. SwiftUI has several tools for state management. The simplest one is @state. State creates a new internal source of data for a view. When you mark a view property as @state, SwiftUI manages its storage and provides it back for the view to read and write. This view, for example, allows people to rate a pet's tricks. It's using state to keep track of the current rating, allowing it to change over time. The value is displayed prominently in the middle, and it has 2 buttons to increment and decrement the value. SwiftUI maintains the value of this state behind the scenes. When the button is tapped, its action is called, incrementing the internal state of the view. SwiftUI notices this change and calls body on rating view, which returns a new text value. The result is then updated on screen. To add animation to this state change, just wrap with animation around the text. Here, SwiftUI applied a default crossfade animation to the text, but you can also customize the transition. In this case, using a numeric text content transition fits perfectly. SwiftUI automatically provides adaptivity along several dimensions. The app already looks great in dark mode and supports several accessibility features, such as dynamic type. Many components across SwiftUI have this same adaptive quality. One example is searchable, which is applied to the list of pets here. SwiftUI takes care of all the details to make that happen in an idiomatic way. And through incremental adoption of other modifiers, you can customize the experience, such as adding suggestions, scopes, and tokens.
SwiftUI's declarative and adaptive views pack in a lot of functionality in just a few lines of code. There are controls like button, toggle, and picker, container views like navigation stack, tab view, and list, presentations such as sheets and popovers, and many more examples that you can explore in the documentation. And when you are ready to create unique, custom experiences, SwiftUI also has another layer of API that provides low-level control. You can build your own control styles, use Canvas for high-performance imperative drawing, create completely custom layouts, and even apply custom metal shaders directly to SwiftUI views. SwiftUI is available when building an app for any Apple platform.
Thanks for that great introduction. Are you excited to start building? we can't wait to help you get started. And so now we'll go to your questions. Our first question comes from Donald, and I think I'll start this one off with you, Jeff. So the question is, as a beginner, I'm confused. Should I use React Native or SwiftUI? Both are incredible, but I think React Native allows me to release on both platforms. Can you introduce some of the advantages of what SwiftUI can do?
Sure. So I would say that one great advantage of SwiftUI is that it's intimately tied to all of Apple's platforms. And so when we introduced a new design language, for example, Liquid Glass last year, you get a lot of that for free just by using our native UI framework in your apps versus something like React Native where you might not be getting those same platform advantages. We also evolve the behaviors of our APIs over time to take advantage of new features in our devices and our operating systems as well.
Yeah, one of the things I get to do in my role as a technical evangelist is go out and meet with lots of developers. And one of the things we saw in our workshops about the new design was, so the new design released at the same time as some design changes on other platforms, and we sort of all went in different directions. And the developers that had chosen a cross-platform framework were finding that they were landing in an awkward middle spot. They weren't adapting to the platforms as they were. And so those folks were moving away from multi-platform frameworks and towards native frameworks on all the platforms that they deployed on, because they were finding that the seeming efficiencies at the beginning actually meant a lot more work at the end and more work at a time in the production cycle where it was hard to adapt. And so I think, especially when we have agentic coding that can let us move so fast at the beginning stages of a project, making the final polish stages easier is sort of the thing to emphasize.
Yeah. There's also like the aspect to it that SwiftUI is built on Swift, which is like a really incredible programming language. And so just by using SwiftUI, you're able to leverage like the power of this incredibly performant, expressive language, which is something you don't get with some other non-native frameworks.
Yeah, yeah. All right, the next question, and I'm going to try to read off this person's username. AI did Lutfi. As an accounting student with zero knowledge in coding, and Seema, I'll let you take a first crack at this. What's the best approach to learn coding and building an app with SwiftUI?
That's a great question. So the way I approach this, and like I would recommend approaching this, is kind of just think about your life. What is like one of the problems that you encounter every day, or like think about your family. Like what would be an app that would help them, and that would motivate you to come up with an idea that would be helpful for you, your friends, and family, and then you get to share it around and see them use your app and actually improve their life with it. That's how I also years ago got into iOS development, and then I think nowadays with agentic coding and Xcode, you get to build it faster and see it come live on screen in minutes, and it's great. And actually this year we have enhanced our agentic coding capabilities in Xcode with some of the skills that can help you build even better experiences. So yeah, go ahead and give it a try. Yeah. Hopefully it works out great.
And I love that idea of finding some little problem or thing you want to build. Find what that spark is. I think it might be kind of fun to talk about what some of our first apps were when we got into this. Seema, are you willing to share what one of your first apps was?
Yeah, I have two. The first app I built was a Pomodoro timer, because back then I was very into kind of organizing the way I work, and I liked some of those productivity tools, and I wanted to build a custom experience for myself, and I really enjoyed customizing the app for me and kind of seeing myself take advantage of using it and actually make my work more productive. So that was my first app.
Nice. Anybody else want to share a first app?
I got a good one. When I was a little kid, our dogs, for my family growing up, used to jump on our bed all the time. And I just started learning about iOS development. And the only way we could find to consistently get them to get off the bed was if they heard our doorbell sound. So I recorded our doorbell sound. I made an app that we called Dog Bell, where you could just press the button and it would make the dogs jump off the bed.
Oh, that's
very useful.
Yeah. Anybody else have one?
I think one of my first ones, but this was probably with AppKit, because this was a while ago, was a to-do list app, because I was always forgetting to do things. And I probably also didn't spend enough time on it, because I'm sure I forgot to finish it.
Nice, excellent.
I learned iOS development at Coding Bootcamp, and they had a ping pong table there. And my friend and I, that were just learning, we would play ping pong all the time when we would take breaks. We would always argue over the records, and who was better. And so we, at one point, just built a little app to keep track of who won more games historically.
Who was better?
He was much better. It turns out I knew that all along.
I should have kept track, apparently.
I made an app specifically for color blindness. So as somebody who has red-green color blindness, I found that it was really enjoyable to actually go through the process of making an app and kind of adjusting it for my own needs for day-to-day, figuring out differentiating things, and kind of making an app that felt natural to the way that I work, I come about my life.
Nice, I love it, excellent. So thanks for sharing. Our next question comes from Sehan, and maybe I'll start with you on this one, Trevor. Sehan writes, I'm a CS student just starting iOS development. If your goal were to become a highly skilled, job-ready iOS engineer in 2026, what roadmap would you follow from Swift fundamentals to advanced app development? And which skills would you prioritize most? There's a lot there. I think we're all going to be able to jump in.
Yeah. I would start with Swift, right? That's the basic building block, right? Make sure you have a good understanding of the basic language that you're going to be working with on iOS. like Swift can be really different if you're coming from another language, the type system, concurrency, right? There's lots of features that are going to be kind of new and really interesting, and honestly, I think really great to learn from the start versus maybe learning unsafe habits in another language, where like Swift will kind of enforce those things for you and allow you to learn them along the way as you're learning, which is great. And then I think the fun part becomes diving into Swift UI, building like a basic app, something that you're going to have fun with, one of those things. There's some really great resources online for Swift UI. The online interactive tutorials, I think, were the most incredible introduction to Swift UI. When I saw animations in there, something like really clicked for me. And that would be, I think, the first couple months. There's a ton within just those two things, but that's where I would start.
Anybody have anything to add to that? I think one of the things that that I think is going to be valuable is like use the agentic tools, make those part of your learning, but make sure you're thinking about the output they're producing, right? The goal. So I was a teacher in a prior career, and when a teacher assigns an assignment, it's not because they want the answer. They know the answer. What the teacher is looking for is they're trying to give you practice on an area, right, to up-level your skills. And you can do the same thing with your own work. If you have an app you want to build and you're using agentic programming to help you get started, look at the output, understand what it's doing, engage with it deeply, not just at the surface. Anybody want to?
Also, I was just going to say, quick add-on, when it comes to like using LLMs for programming generally, or for learning specifically, treat them like tutors. Like you can just, instead of just having them generate code and like looking at it and studying it, you can ask them questions about it. Right? Like it is really like having an interactive thing with you that has a really deep domain expertise on a lot of stuff. So
that's totally what I was going to get at too. Is like I feel like these tools are really great at explaining concepts, and so this can be a really valuable tool to learn some of the underlying kind of CS concepts as well. Especially when you're building an app, you need to know a lot more parts than just the UI, right? There's networking calls and data storage and all that, that it could probably do a great job explaining some of the underlying algorithms that you might want to use for some of those pieces as well.
That gets another kind of interesting thing you can do with these. Like instead of asking the agent to write some code for you, you can take a stab at writing the code and ask the agent for a code review. It's like, what could I have done better here? What were there APIs I should have considered or looked at? And so it's nice to have that tutor in your pocket. It's kind of cool. This is a great question. Sam, I'm going to start with you on this one. Since you covered this in our little intro segment. So this is from Will Pix. For a beginner coming to Swift UI, what exactly happens under the hood when I use @state? Why can't I just use a standard Swift var for data displayed in the UI?
Yeah, so one of the big concepts behind Swift UI is that we want views to be like very lightweight descriptions of like the actual thing that's getting displayed, rather than like some long-lived thing that sits around and you change over time. But we do still need some place to like store the information that is going to change over time. Like we have a counter that's incrementing, or just some value that needs to like change over time. So what state says is, hey, Swift UI, take this value and like own it, make a persistent thing that you can kind of keep around, a little box for it, and it does this under the hood. It makes like a little, it like allocates a little piece of memory, which just lets it sit with this value, and then it gives you the ability to read it and to write it whenever you have like closures that change. And the combination of these tricks basically means that you don't have to think too much about like where the values are getting stored, or like memory allocation, or any of like the complexities under the hood. You just make the value and change it.
Yep. So that I think. For folks who maybe have more like a CS background, or coming from for apps like UIKit or another sort of traditional object-oriented framework, I mean, it's not required to have that background to use Swift UI, but that sort of difference that a Swift UI struct is a value that describes the view. And so Swift UI is like making an instance of it. It's grabbing the state that you have stored away, putting it all together. It's rendering the pixels, and then just throws it away. And the pixels are on the screen, and memory is preserved for other work now. And so that's sort of one of the things that's really different about Swift UI is like you've got this template for what the view should look like. It pulls all the pieces together, puts the pixels together, and then it's on its way.
Yeah, I do think that for lots of people who like start out with Swift UI, a lot of times it's confusing in terms of like when should I use @state, or like when should I just like store something as a variable on the view struct. And as Sam, I think I heard you just touched on, Swift UI will recreate your view struct many times as your parent view updates and just through like your app's lifecycle. And so it sometimes becomes harder for you to kind of use this just the normal property, because it'll just get thrown away every time. And so I think state is a great tool to kind of let Swift UI kind of store this value away and kind of keep it there alive for you, so that every time view is recreated, the new value is available to you, and you're able to actually like change the state.
The Swift language is really nice here, because if you try to just declare a variable inside of a view body and then change it, right, like you'll get a compiler error and you won't be able to build your app. And so like at least you have that nice warning to say, hey, use @state here to key Swift UI in on knowing when it needs to redraw.
That actually loops back to our first question. Is like why, and part of Sam's answer to that is why choose Swift UI? Because it's embedded in this type-safe programming language. The compiler is going to find your mistakes for you instead of having to tease them out at runtime.
I always find it miraculous when using Swift or honestly any strongly typed language, how often your code compiles and then it just works after compiling. It's sometimes feels a little miraculous.
Yeah. Full disclosure here, Sam and I are both programming languages nerds, and so anytime you give us a chance to talk about programming languages, we will, and we won't shut up.
Yeah.
But in order to keep that from happening, and also because this next question names 4 programming languages, Gabriel, I'm going to start with you on this one, and then maybe throw to Jeff. This is from MKWB. I'm primarily a web designer with knowledge only in HTML, CSS, some PHP, some JavaScript, and some Lua. It's a pretty good list, so don't sell yourself short. But I'm interested in learning to develop apps for Apple platforms. How easy would it be for someone with little to no traditional coding knowledge or skills to get started with Swift and SwiftUI?
Yeah, it's especially for someone who already has experience in stuff like Lua and JavaScript, it's pretty easy. First of all, in terms of Swift as the language itself, it is very similar to many other C-like languages, so you'll be well at home with the syntax. A lot of the concepts will make sense to you if you've done JavaScript. And in terms of SwiftUI as the kind of embedded language, a lot of it kind of feels similar to what HTML and CSS will be. Obviously a little bit tangentially different, but a lot of the concepts and the kind of immediately apparent hierarchy that you're used to by reading through HTML is kind of the same way that you would declare your views in SwiftUI. And I want to stress, don't underestimate the knowledge that you already have. It's a huge starting point to have any coding knowledge at all. And Swift enforcing things at compile time, and there's also a whole bunch of developer documentation, especially now with these agentic tools that are readily available for you. What I find particularly helpful, so I'm somebody who started with Swift, and I've now needed to actually dabble in Objective-C for various reasons, is I find it actually useful to use these agentic tools and ask them, hey, I have this concept of this flow written out in Swift. What is the idiomatic way that this would look in Objective-C or something like that? And having that kind of back and forth to say, taking this knowledge that I already have, can you help me convert my mental model into a different idiom?
Sure. Jeff, I feel like Gabriel's answer sort of started us walking back your career history.
So for context, many years before I came to Apple, I started basically doing HTML and CSS, maybe not any PHP. And when I started working on SwiftUI, I found it very similar to doing that before, especially in terms of how you describe the structure, like Gabriel was talking. So I'd also say that a lot of our kind of layout concepts feel pretty at home if you've been working in kind of building web pages and stuff as well. So it sounds to me like you have a great start already.
Yeah. Also, the web is was the world of declarative frameworks before Apple platforms were, right? HTML is itself declarative, and then there are a bunch of frameworks built on top of it that are declarative in a very similar way to SwiftUI is. So if you have any experience with those, that helps too.
The other thing I'd mention, I think, is if you're coming from the web, you're used to a browser that's updating as you're making edits, which is a little bit different than sort of a compile and run architecture that most native languages have. Check out previews in Xcode so you can see the dynamic updates. Now with Device Hub in Xcode 27, you also have options for showing the simulator right there or actually pulling a mirror of your device on screen. And so there are tools for getting those instantaneous previews, but I think that is one of the road bumps that people hit. And so make sure you check out previews and use that to see how to sort of preview what you're working on. Trevor, I think I'll throw this one to you to start here. This question comes from Classic Flame. My question, where should I start? Especially in SwiftUI, there's so many tutorials, even on the Apple developer side, and it's a little bit confusing what to do first. Where should I begin? I'm a Java developer and want to begin with iOS programming. Thank you.
Like I mentioned earlier, those initial tutorials, I don't can we link those somewhere?
Yeah, I think we have a mechanism for doing that. I'll ask our folks in the back room if they could respond in the thread with links. Knowing the folks in the back room, they may have already done that.
I think those tutorials, there's a series of tutorials that will walk you through everything from here is a view body to state to animations, right? And here's how data flows in SwiftUI. It will give you a really, really solid foundation to start with, and I think that is probably the best initial set of resources. Personally, I think when I started learning SwiftUI, I worked through Paul Hudson's 100 Days of SwiftUI. Yeah, which I think lots of people have found that super helpful, and that's a great little, very bite-sized chunks of content that are great.
Yeah, to add to that, I going back to the community resources. There are lots of books people have written about iOS development, lots of articles available online from other authors we have in the community. And the official Apple tutorial is great because not only it teaches you SwiftUI, it also teaches you how do you then make your app more production ready with, I think they also discuss some of the common data storage solutions and databases and how to wire it up to your app. So there's lots of depth there, so definitely start there. And if you feel like it's lacking some of the details, there's always the community resources that can walk you through.
And I actually want to throw back to your first answer, Seema, about getting started. It's sometimes it's instead of just all right, I'm going to do all these tutorials, these are what I'm supposed to do. Sometimes it's a matter of no, this is what I want to make, and then let that guide the tutorials, search or ask the agents. Yeah,
that's the most effective way. I also feel like is to learn those tools, because when we have the goal of like, I want my app to do all these features, and it's like, okay, what are the tools that get me to implement those and wire them up all together so that the app does what I initially intended it to? And that's the best way for you to learn. And even if you're following like a tutorial online on like how to build like a certain kind of looking app, I would encourage you to like think about what would be another feature you can extend this app with to make it more personal to you, not just what the tutorial shows. And that's going to help you kind of really solidify those concepts that you read about.
Yeah. And there's just so much satisfaction in like building something that solved the problem you had. Yeah.
This did make me realize that we haven't talked about the human interface guidelines at all, which is another great resource on the developer website, which can walk you through some of the kind of design concepts that are common to Apple's platforms and help make your app feel right at home on whatever platform you're developing for.
Yeah, and that actually raises another thing I really like to do to like learn part of an API or something is like play around with other apps. Like there's this really cool thing in Mail. If you're in your inbox and you scroll up, the inbox title flows into the title bar, and then the number of messages like animates in behind it. And like it's just a delightful interaction. I'm like, wait. And I guess I work at Apple. I could have just gone asked, how did you build this? but I wanted to learn, and so I like tried to figure out how would I build that with the pieces that are in the API. And so it's kind of fun to do that. I'm like, oh yeah, that's just code. I can do that. So I really enjoy that part of the experience too. All right, so this is a question that may call back to our conversation around state. So I'll start with you, Sam.
Sure.
This is from Charlie. Charlie asks, what are the best practices in SwiftUI to handle frequent real-time state updates like sensor data without causing unnecessary view redraws or lagging the UI? I'll throw to you after this, Gabriel. I can have something to say too.
There's a lot of tools at your disposal here, and it's really going to depend on like the specific kind of data. But if you have things that are updating on like a per frame basis or very very frequently, just add observable is a really good tool for these kinds of things. If you put data in an add observable and then you use it in various parts of your app, SwiftUI makes sure that only like things that changed in your observable actually cause UI updates. It's very specific about that. Other things to make sure of are like make sure you're not like updating like values that are dependent on various places in your UI in like at too high a frequency, right? You want to very much limit your dependencies.
Yeah. Gabriel, do you have a follow-up on that?
Yeah. So and like what Sam was saying, like you kind of want to make sure that you have as cheap a view body as you can get, as much of like a leaf view, if you may, for these types of like rapidly updating things, because you don't want to have a situation where we throw away large chunks of your data and have to redraw that. And also, if you have content that is like a series of content, there's stuff like timeline view, and also if you need lower level control, you also have things like lazy stacks where you can kind of consolidate the information that you have directly to whatever is in your viewport. A lot of these optimizations are also handled for you if you have stuff in like a for each. So if you have a for each that lives inside of something that is lazy, like a lazy stack or a list, you can kind of be rest assured that we will try to make sure that we're only invalidating and redrawing as much as we need to. But yeah, so keep your view bodies small and evaluate where you can make things lazy if you can.
Yeah. So a couple other things I would add to that. If you have something that's updating per frame, I would ask the question, does your UI actually need to update per frame? Or can your data model compute some semantic value? Like let's say you really have 3 states that you're computing between something that does update at a very high frequency. Right. Then you only have to reevaluate your view body whenever you transition between those 3 states, and so you can get a lot of performance gains there. And then the other like just general best practice is avoid putting those things in the environment, right? Because you may invalidate a lot of views downstream of that.
Yeah, and to add to that, I also wanted to touch on the concurrency angle a little bit. I think it's very easy when you have something like timeline view or something kind of updates per frame, kind of accidentally like start doing like some asynchronous work, and that can add up quickly. And SwiftUI views work best when the inputs to the views are more synchronous, and you kind of keep most of the async stuff like outside, and then you also get to test that and really like reason about it a little bit better. And that also helps us make your animations way smoother and view updates work more expectedly.
Yeah. Also, just to quickly bring it back to somebody who's maybe a little newer to the framework, I think that the thread across all these pieces of advice is like break things up into small reusable pieces. It'll both help with like your code organization, so you can understand the things you're writing, but it also plays really nicely with SwiftUI's performance model. So that's how you'll get the best code.
Yeah.
Sorry.
No, please.
I was gonna say, if you're just getting started with this too, like you can take a lot of comfort in that SwiftUI manages so much of this for you, right? And so like there's no need to get really stressed out about this performance right off the bat, right? You're gonna get really good lazy performance out of SwiftUI just by using it naturally, and then optimize when you need to, right? Like profile and try to.
The SwiftUI instrument is really good for profiling. It really helps you get a lot of insights about like, where you're spending time.
Yeah. So instruments is an advanced tool. It's probably not something you're picking up on the first stage of your journey. But if you're coming from maybe another one of Apple's UI frameworks to SwiftUI, maybe you know instruments already. So like not all beginners are to SwiftUI are beginners in general.
You can like start by trusting SwiftUI's laziness, and then when you start like running into performance bottlenecks, that's when it's a really good time to start breaking out the heavy hitting tools and doing some analysis.
So Charlie, that was a great question. Clearly we have a few on that one, so I appreciate that. So the next question, and Seema, maybe I'll start with you on this one. This comes from Ichicho, and the question is, has Apple Intelligence within Xcode been fed with all the information and documentation around SwiftUI? Having tried to vibe code with Gemini, its ability was okay, but often hit recurring issues with Swift.
Yeah, that is a common issue we see with large language models, kind of sometimes producing a little bit incorrect results when it comes to SwiftUI and some of our newer APIs that maybe the model wasn't really trained on yet. But this year we've introduced SwiftUI skills that actually we've fed with all of our internal knowledge, that all the best practices we have for data flow in your apps, for the new APIs that we introduced, and you get them out of the box when you use agent coding in Xcode. It automatically has access to all these skills, so every time you build a new app, it's going to automatically invoke those skills whenever needed. There is a way to export those skills to use with those other third-party models that you may be using. We did cover a way to do that in What's New in SwiftUI talk, so go ahead and check that out. I think it mentions that like in the very last bit of that talk.
Yes,
but it is
the third to last slide of What's New in SwiftUI.
Yeah.
So watch to the end.
Yeah.
Anything to add to that? I think that sort of sums it up. And the nature of LLMs is they have the data that they were trained on at the time they were trained. And so skills and the other things that we're adding are a great way to level them up as we level ourselves up.
Yeah, and also they're always evolving. So, I mean, if you find that it is stumbling in the new Xcode skills that we have, please file feedback. It'll really help us out in improving these tools for everybody.
Yeah, but we did find that the models got significantly better like reasoning when they were invoking those skills. So we're sure that the skills should provide greater kind of comfort when using those models.
Also, while you're mentioning filing feedback, if you're new, especially to Apple platforms development, file lots of feedback about everything. Any issues you hit in the betas, even just things that are like confusing to you about the framework. Getting to hear your thoughts on the tools we're shipping is like how we decide how to evolve them. So
yeah, and there's two ways to give us that feedback. If you're running the betas, their Feedback Assistant app is part of all the betas now, so you can file feedback right from your device, whether that's your MacBook or your phone or your iPad. If you aren't running the betas, but you're running, whatever you're running, I guess, but like especially feedback on the skills that we've added in Xcode 27, you can go to Feedback Assistant, all one word, .apple.com, and that's the other way to file that if you don't have the betas installed.
Do developers need to do anything to enable the skills, or they're just kind of there by default?
They should be there when you go to Xcode and you like invoke the coding agent like window or like your prompted model. The skills should be already loaded, and I think that they would be invoked like based on the context of like what the.
So you have a SwiftUI file open, and it's going to kind of know.
Right. Yeah. So it should kind of refer to the appropriate skill when needed based on the context, which is great.
And if you're using an LLM outside of Xcode, make sure you check out What's New in SwiftUI so you can export those skills because those will not have that baked in by default.
Right. And let me try for a segue here. Our next question's from Aziz, and Aziz, and I think I'm going to start with you on this one, Jeff. So it's back to the performance question. What are the best practices in order to make my SwiftUI views performant and not have unnecessary view updates? And the segue here is that the agentic coding conversation in Xcode is implemented in SwiftUI, and it's highly performant. And so it's definitely possible to make highly performant code with SwiftUI. But I wonder if we could talk a little bit more about what are some of the best practices. And we talked about breaking views down, but is there any more we can say there?
Yeah, and I think we talked a little bit about using observable. This is like a really nice tool because the way it works is only properties that change that are also read by your view will establish that dependency to kind of reevaluate the body. So if you change a property that is only read by say one view or two views, then only those are going to update, and you don't have to worry about any unnecessary updates outside of that.
Yeah, and I think that gets at the mental model that I find helpful for thinking about SwiftUI view updates. Like if you've got a view and it's got, and I hope this works on, let me draw with my hand. But if you've got a view and it has a bunch of subviews in it, and then they have subviews, and so it sort of forms like a tree. When the view at the top has to run its body, anything that it reads will cause its body to run. Then it instantiates the views underneath it. But if they haven't changed, we don't need to run their bodies. Like it just runs that one at the top. But similarly with like observable, so if you've got an object that represents the data that you're showing, if there's a view way down the tree and it's the only one that reads one of those pieces of data, then only that little one down at the end needs to update. And so like if you look at your views and you've got a view that is reading every single property of some observable, well, that view's going to update a lot, right? And so that's an opportunity to maybe break out some pieces of that.
Yeah, one advice I have is also, and I think we touched on that, but make sure to, with environment, make sure to kind of only read the environment that you're actually using in view's body, because every time environment changes, we also have to invalidate all the views that read it so that they stay up to date. And it is an important kind of thing to watch out for, to like keep the unnecessary environment out of sight.
Yeah. So environment. So for folks who haven't experienced or worked with this yet, environment is a mechanism for injecting some values at the top of a view hierarchy and then being able to read it down at the leaves without having to pass it along every time. And it was really designed for things like color scheme, screen size, stuff that doesn't change rapidly. You can also pass observables through it, and that works fine because they're only updating at the point that they're read from. But avoid, and that's what you're saying, Seema, avoid don't pass the current time in milliseconds in the environment because everything down the tree is going to be updating all the time.
Yeah.
I did want to get back, I guess, a little bit to what you said earlier about breaking things up. I think this is also a really important thing to think about in terms of trying to make your view bodies kind of as small as is reasonable for what they need to do, and kind of extracting out pieces into your own custom views and spreading things apart that way. It's also a great tool for being able to reuse components across different places of your app.
Yeah, another to add to that, a great way to kind of spot check those places is sometimes you notice how you add the same set of modifiers in different parts of your view hierarchy, and that's a great way to take those modifiers and kind of abstract it into a custom modifier that you can then apply. And same thing with some bits of your views that are look repetitive across the app. You can kind of take them into custom views and then reuse them, and that's going to make your code more maintainable, more readable. And yeah, I think it's a great way to kind of go about that.
Yeah, I love that.
And there's a couple of things I saw talking to developers in the community and questions that came up a lot that are also related to performance. One way people will sometimes try to simplify a view that has a very large body is to pull pieces of that view out and put them in computed properties in the same view. I wonder, you're smiling, so I'm going to take this to you, Trevor. Is that effective, or what's the right approach there?
I think it's just inferior to refactoring that chunk, that chunk of the view into its own custom view. And there's a couple reasons for that, right? One is if you, let's say you have a button that's at the bottom of a view, and it's some custom stack of buttons, let's say. If I refactor that into its own custom view, then one, SwiftUI can only reevaluate that view body when something that it actually relies on changes, so you can get better performance there. But two, now I have better modularization of my code base, and I can go reuse that stack of buttons somewhere else. It can help with testing, right? There's so many other benefits that you would get by just moving it into a custom view. And personally, I think it's much more readable. So I would avoid that pattern of these computed properties inside of a view.
I feel like it does also depend on your use case, because sometimes if the property is really small and for readability, it's fine. But because sometimes when you're moving to a custom view, you also have to move some of the state into it, and maybe you're only planning to really use that code in one view. So it really just depends on your usage. But I think the general guidance should definitely be abstract more pieces outside of your view and put them in the custom views. I think it's a great guidance in general to have.
Yeah, from a performance standpoint, moving something out of body and into a computed property doesn't actually buy you anything. Yeah. It's as if it was in body. It really is only a readability win. So until you break it into a separate view that SwiftUI can invalidate separately, you don't get the performance improvements.
Can I say two more things on this?
Yes, please.
Sorry, I have so many I did on performance apparently. Avoid doing any heavy work inside view bodies because they may run frequently, right? So one example I think it's easy to reason about is you might create a number formatter inside of a view body to format some number that you're showing inside of text, right? Can you create that number formatter somewhere else that's cached, that's not being allocated every time your view body runs, right? So if you can avoid those little things, those are easy refactors.
Array transformations are another one that people run into with a for each and things like that that are often a problem.
And then the second thing is don't worry about this too much if you're just starting SwiftUI. Right?
That's good.
It's going to do so much for you.
Also,
it's good performance out of it.
All of this guidance is in the skills. So if you're using a model to generate that code, it should automatically put refactor views into smaller views. So that's great, I think.
And that is a perfect segue to our next question from
really on it with the
N58. I feel like Sima might be reading ahead. This is from N586FL. Rolls off the tongue. In a world of agentic AI, what is the effective way to leverage AI within Xcode and SwiftUI to help ensure that the student is learning SwiftUI and not just having the AI write the code for them? And is there an effective learning plan that incorporates AI without derailing people's education? And the teacher in my heart just loves this question. It's so important. Any thoughts on this? I would love anybody to chime in.
Ask questions. Ask AI questions. When you see it spit out a chunk of code and you don't understand what the code is doing, ask it a question hey, what is this doing? And if you have an idea in your head that's oh, maybe I could have done this differently, then ask it again and be hey, could I do it this way? And how can I accomplish that? And then I feel that is the most effective way to learn. And I think if you don't ask those questions, you'll quickly find yourself in a situation you have an app, but then you're trying to add something to it, but you feel you don't even know what how the code is structured and where should the new piece go. And I think kind of building that confidence with your code through asking those questions is a great way to learn.
And I think Sam was mentioning earlier, it's really treat it like a tutor, especially when you're a beginner. When you're more advanced, you might feel more comfortable kind of trying to put as much speed into your work as possible. But when you're a beginner, treat it like a tutor. You're asking it questions. When it's writing something, it's supposed to be an informative thing. A tutor's not going to tell you the answer to your question and then just leave it at that, right? That it doesn't do anything for you. So when you get something generated by an AI, definitely be interrogative about it. Ask a lot of questions. If you don't understand step by step what the AI is writing, try just hammering home what is this code doing, because it's one of the greatest ways to learn, because you get to experiment really fast and you get to learn concepts basically on the fly without even having to have some pre-recorded things. So
Also, like as you go up the skill curve too, and you are getting to the point where you're like more comfortable and making a lot of the decisions for yourself, I encourage people to like treat LLMs like less like an employee and more like a coworker. Like, you know, when I'm working with anyone on this panel, like so often I'll be like, hey, I've got this idea, I want to build this thing. Here's what I'm thinking. Like, what do you think of this? Like, is this at all correct? Like, and you sort of go back and forth, and then it will, you know, give the LLM or your coworkers will like give you an answer, and then sometimes you push back on that answer, and it's like this real back and forth, and like that's how you learn stuff.
It's the most sophisticated rubber ducky we've ever invented.
Yeah, seriously, exactly.
Totally.
Yeah. I mean, to me, I think like programming is a very creative endeavor, and it's important, you know, at least to me, that like I maintain that when doing it. And so I think everyone needs to find the right balance between how they want to use these tools and also, you know, get the creative enjoyment out of building whatever apps they're building as well.
And I think you know, having taught computer science, one of the really like fascinating things to watch as students sort of grow is you start being able to think in bigger chunks, right? The first time you sit down with a programming language and you're like, let x equals 5, like this whole idea of storing something is a big deal, and it takes a bit to wrap your head around. And then you got loops and methods and classes, and we've been moving up and down this abstraction hierarchy in our conversation today. And one of the things about the LLMs is like they can go to the fully abstract end of it, right, and skip right over sort of this foundational knowledge. And so like maybe take smaller steps, like explain this loop to me. Why does that solve the problem? Or I need to do this thing. What are 3 options? Okay, then I can ask the LLM questions like, well, why would that be a good option? What's interesting about that? Or why might this be a better option? And it's like with an LLM, you can be the wonderful or annoying student who's like raising their hand to ask a question all the time, and it never gets tired of answering them.
Yeah, it's like maintain your curiosity, basically.
Yeah. You mentioned like the pros versus cons of an approach thing. Like in my opinion, the difference between like a good engineer and a great engineer is their ability to like look at multiple possible decisions and like weigh the trade-offs between them. So like making sure that you're not letting the LLM do that part of the analysis is, I think, really important.
Yeah, I was about to say like the same thing almost, where like in like engineering generally, there are like many ways to accomplish one solution, and maybe one way is like more performant than another one, or like maybe it uses a different tool. And I think when you kind of master some of those concepts, you're able to kind of tell, okay, for this use case, I'm going to use this tool, like I'm going to use this data structure, and like through this kind of prompting, you'll be able to discover all these tools and kind of see like given this specific example I have, like what would be the best approach? Because I feel like it can seem like the solution is like there's only like one solution to your current problem when you're like using LLMs, but in reality there can be many alternative approaches that like you should be able to kind of weigh on and like figure out like what is the best one.
It feels like the culture around coding with LLMs right now has moved so much to like, how do we produce more code faster, right? And like at the end of the day, the goal isn't code, right? Like the hard part is understanding. And so I still think like, maybe I haven't moved up the skill curve, but 90% of the time that I'm using these things, I'm just using them to like build a deeper understanding of the code I'm working in. And like, I still find as an engineer that is like, they're incredible for that. And if you can like avoid the trap of like, how do I just produce more code and think like, how can I use this to like really like gain a deeper understanding that I might not be able to otherwise, I think that's an incredible way to leverage that, especially as a beginner.
So we're the clock says we've only got about 5 minutes left, and we've got a few questions queued up still. So maybe we switch to game show mode and see how fast we can click through these. So feel free to interrupt your teammates if you think they're going to run out the clock. But let's see how many of these we can wrap up before we wrap up. So next one, and I'm just going to send these down the line. If you need a pass. So Sam, we'll start with you. Okay. Noelle Linger. So now I'm blowing our time by Noelle Linger writes, I'm looking for a high-level resource to build a clearer mental model of SwiftUI. Is there an official one-page overview, chart, flow diagram that explains how these pieces fit together and what options developers have?
I forget what they're called. It's not a document, but there are a lot of talks that were released, especially like around the
Yes, we
days
did Intro to SwiftUI, where Jacob codes up an app using sandwiches. He doesn't actually use the sandwiches to make the app, but it's not about sandwiches. And also we have SwiftUI Essentials video. And there's a great one-pager on getting started with SwiftUI on the developer.
Yeah, definitely check those out for me. I've always found like the sessions are killer. They teach so much so quickly, so I can't recommend enough giving them a watch.
All right. Trevor, you get the next one. From Fossil Coder. I feel like a kindred soul. When I use AI tools to write SwiftUI code, I keep hitting the same errors. Code looks right, but won't compile or behaves unexpectedly. How can I use Xcode's AI tools more effectively as a beginner so I'm learning correct SwiftUI patterns instead of picking up bad habits from broken suggestions?
Seema, you might be better at this one than I am. The answer is skills.
Yeah, you should, again, like third time of me kind of plugging this, but like in Xcode 27, check out the skills. We really like put all the best practices into them, and like the models should be able to kind of pick them up and use the best practices we recommend without those like bad patterns. So yeah, check it out.
Also, if you can allow the model to check its work by compiling, right, the beauty of Swift is it moves so many errors to compile time. Right. And so the model can find those and iterate on its approach.
Yeah. And I would also say, go piece by piece when you're starting out. AI models have this tendency that they really want to like one shot implement everything at the same time, and that will often lead to errors. So piecemeal it, take as much of it apart as you can.
And I think that's going to produce better code because it's going to be more encapsulated. So.
Yep, for sure. Gabriel, I'm going to throw this one to you from Florentine F. What's one thing announced yesterday that you think beginners will overlook or will matter very much as they grow?
Okay, so layout flexibility. We had a lot of stuff in this area, and generally with this year we've done a lot of like layout improvements. But layout flexibility is a really big thing, especially because your iPad apps and macOS apps and Vision Vision Pro apps all kind of fall under this umbrella of resizability. And now with iPhone mirroring, your iPhone apps are also resizable. So it's really important to see how much of your app can you make flexible with SwiftUI. We have a lot of constructs. And as you get more advanced, you can even dip down into some of the more complicated things like making your own custom layout when things start to get complicated. Yeah. And also Device Hub is a great new application that lets you test all sorts of things, all sorts of aspect ratios. It's really a great resource. So
yeah, I know when I was starting out with iOS development, I only built apps for the size phone that I had. Because that's what I was testing on. And so Device Hub is going to be great and resizable previews for testing on different sizes. So all right, I think we can get one more in if you're fast, Jeff. This is from Matasa LE. How to best convert a design of an app from a designer to SwiftUI? Do you recommend the Xcode coding assistant? And if so, which one?
Oh, wow. I can't say this is ever something I've had to do. I would say probably I would go about it by looking at what they've built and considering the various layout primitives that we have in SwiftUI and kind of using your own translation engine to do that. I don't know if we have a skill that will handle this automatically.
We do not.
We also have connections too.
I was about to say about the Figma connections, and we have Sketch and Figma connections that produce SwiftUI code given the design you make in those tools. So definitely go check those out. And yeah, I don't know, anyone else?
Yeah, well, I think
dang it.
we have to wrap now. So we're going to leave it on a cliffhanger. Come back and ask the question again at our 9 a.m. Pacific group lab tomorrow, and we can pick up the conversation. But that's the end of this group lab. We're so thankful that you all joined us today and hope you found this really helpful. A big thanks to our panelists, as well as all of the folks working hard behind the scenes to make this happen today. As I mentioned earlier, if we didn't get to your questions, please visit the developer forums at developer.apple.com/forums, where we can continue the discussion or go deeper into code, and visit feedbackassistant.apple.com. File any bugs or feature requests. We really do appreciate that feedback. Speaking of feedback, you should receive an email with a survey link to let us know about your experience with WWDC. We would love to incorporate your feedback into future events. Thanks again for joining us, and have a great WWDC.
Hello, I'm Sam, and I'm an engineer on the StoreKit team. The App Store provides a safe and trusted marketplace for people around the world to discover your apps. By leveraging the App Store APIs, you can offer digital goods and services to customers, while letting the App Store Commerce Platform facilitate transactions and end-to-end payment processing. I'll cover new features in this session to help you merchandise products and grow your app's business. First, I'll share how to expand pricing options for your subscription products. Then, I'll discuss updates coming to the Offer Code Redemption API. And finally, I'll review the enhanced App Store Connect submission experience coming to in-app purchases. I'll start with updates to subscription pricing. iOS 26.5 introduced monthly subscriptions with a 12-month commitment. With this new pricing capability, you can offer customers an option to pay monthly for annual subscriptions. Billing plans can be added to both new and existing one-year auto-renewable subscriptions for your app in App Store Connect. By providing customers with the option to pay upfront or monthly, you can reach a larger customer base and allow the customer to choose which billing plan best suits their needs. Once you compile your app against the 26.5 SDK, customers in available markets can subscribe to the new billing plan inside your app on devices running iOS, iPadOS, macOS, tvOS, or visionOS 26.4. I'll show you how it works by setting up a new billing plan for the SK Demo app. This app uses StoreKit to merchandise and sell in-app purchase products. You can download the sample code project in the resources for this session to follow along. Here, I have the SK Demo app set up in App Store Connect, and I navigated to the subscriptions section. I want to offer customers more affordable options for the SK Demo Plus subscription, so I'll select a product with a 1-year duration. Then, under monthly with a 12-month commitment availability, I'll choose Set Up Availability, and then follow the steps to configure the billing plan. Once created, subscription offers can be configured for each billing plan type. For example, I added a free trial only for the customers who subscribe to a 12-month commitment. Now that I have new subscription pricing configured for SK Demo in App Store Connect, I can merchandise the new payment option to customers with StoreKit. Pricing Terms is a new property available on Subscription Info for merchandising billing plan information. The Pricing Terms array lists all available billing plans for a given product. Every auto-renewable subscription carries at least one billing plan in this array with a default billing plan type of Upfront. Because I configured a monthly subscription with a 12-month commitment for SK Demo Plus, a second object is returned in the Pricing Terms array. This billing plan uses a billing plan type of Monthly, which only applies to monthly subscriptions with a 12-month commitment. To merchandise pricing terms in my app, I'll use StoreKit Views. The StoreKit Views APIs handle the work of loading product metadata from the App Store and adjusting layout, so your store automatically adapts to feel at home across all platforms. I'll show you how it works in code. I'll start by adding the new SwiftUI view modifier, Preferred Subscription Pricing Terms, and attach it to my existing subscription store view. I'll then filter for the pricing terms with a monthly billing plan type. And now, my subscription store is updated and ready to merchandise the monthly subscription with a 12-month commitment. If you want to customize the subscription store view further, check out Meet StoreKit for SwiftUI from WWDC 23 and learn how StoreKit views can match your app with custom icons, backgrounds, and any other changes. To merchandise the commitment plan in custom store UI in your app, fetch products with the product API and filter for pricing terms with a monthly billing plan type. Then, obtain the monthly and total commitment price and display in the UI. Note that billing plan metadata is only returned when available in the customer storefront. To make the purchase, pass the new billing plan type purchase option and handle the result. Before a customer subscribes to a commitment plan for the first time, new messaging is included with the disclosure sheet. The App Store automatically presents this sheet and is displayed once per Apple account. The sheet includes information about the number of payments required to fulfill the commitment, along with cancellation guidance. When a subscription is active, the App Store also automatically provides new UI for customers to manage their monthly subscription with a 12-month commitment. Here, customers can see all available plans and check the number of remaining payments along with when their billing commitment renews. You can present the Manage Subscription Sheet directly inside your app using the Manage Subscription Sheet API in SwiftUI, or in UIKit, call the Show Manage Subscriptions API. To retrieve the active subscription information in your app, you can use new fields on transaction that provide billing plan-specific metadata. For transactions with an upfront billing plan type, commitment info is nil. For transactions with a monthly billing plan type, commitment info returns the progress, price, and expiration for the 12-month commitment. You can use these fields from the latest transaction to check customer entitlements or build your own commitment progress indicator. Always use the latest transaction to get an accurate expiration date. Similarly, you can retrieve the renewal billing plan type and commitment info on renewal info for information on the renewal of the overall commitment. These new fields are available starting with OS 26.4. Once you've added logic to merchandise and unlock content for the new billing plan, you can start testing with StoreKit testing in Xcode. Starting with Xcode 26.5, open your StoreKit configuration file and select a 1-year auto-renewable subscription. Then, using the new billing plan picker, choose monthly with a 12-month commitment to create a billing plan. This creates new fields to configure pricing for the monthly subscription with a 12-month commitment. Similar to App Store Connect, offers can be uniquely created for each billing plan type here in Xcode. Once configured, test your purchase flow with the Transaction Manager and verify commitment info in the Transaction Inspector. To learn more about best practices and setting up StoreKit testing in Xcode, check out What's New in StoreKit 2 and StoreKit Testing in Xcode from WWDC 23. If your app uses the App Store Server APIs or App Store Server Notifications v2, you can leverage new capabilities for customers who subscribe to a monthly subscription with a 12-month commitment. There are new fields available in the signed, transaction, and renewal info objects that provide additional information about the commitment plan. Subscription notifications continue to provide updates on the subscription lifecycle, such as monthly renewals, throughout the 12-month commitment. The Retention Messaging API also supports this new payment option for auto-renewable subscriptions. Check out our WWDC 26 session, Explore Retention Messaging in App Store Connect, to learn how this server-to-server API can help with your customer retention strategy. I'll now show you a transaction payload example from the server for one billing period purchase of a 12-month commitment. This decoded JWS transaction includes new fields that correspond to the ones I covered earlier in StoreKit. Use these fields to detect billing period purchases and understand where they live in the context of the overall commitment. The signed renewal info object contains similar fields, which reflect the renewal preferences of the customer after the current commitment ends. Accordingly, they are only present in the renewal info when the subscription is currently in a commitment. In this example, the customer changed their subscription to renew into a different build upfront plan once their commitment completes. To learn more about handling renewals and other events throughout the 12-month commitment, check out the developer documentation for managing the lifecycle of monthly subscriptions with a 12-month commitment. In addition to new pricing capabilities available on annual subscriptions, I'm excited to share that there is another new feature to expand your subscription offerings: bundles and suites. Offering subscription bundles and suites is another way you can provide customers with more value in their subscriptions across apps. Let's review the difference between bundles and suites. A bundle is a group of subscriptions which can be purchased individually, but are sold together in a single purchase and offered at a better price than purchasing all of the subscriptions individually. A suite is a group of subscriptions which only exist in the context of the suite. These subscriptions cannot be purchased individually, but together typically provide service to a related set of apps. You can start testing the APIs for bundles and suites in Xcode 27, and more details in this program are coming later in 2026. Shifting gears to offer codes. Offer codes can be added to a consumable, non-consumable, auto-renewable subscription, or non-renewing subscription product, and allow you to provide free or discounted in-app purchases to customers for specific duration. To learn how to configure offer codes in App Store Connect, check out Implement App Store Offers from WWDC 24. Customers can redeem offer codes directly within your app when you present this sheet using the Offer Code Redemption API. Similar to creating a purchase, the API now returns a verification result when the redemption completes. The API also accepts a set of redeem option values that configure the code redemption. If the redemption succeeds, you receive a transaction object in the verification result. If the redemption fails, you receive an error that describes why the redemption failed. A UIKit variation of the updated redemption API is available as well, using Present Offer Code Redeem Sheet. You can now test redeeming offer codes in Xcode 27 with the new redemption API on all applicable product types. When you're ready to submit an app to the App Store, you can utilize the enhanced submission experience for in-app purchases in App Store Connect. This includes the ability to group multiple products as review items into a single app review submission. In-app purchase products can now be combined with other review items, including in-app events, custom product pages, and product page optimizations.
Hey folks, I will stop my streaming now. As I got to catch up on my sleep. There are some important sessions that are being done right now. And the frequencies currently do not allow me to work, as some of the malicious assholes are playing the sleeping frequencies right now. So that's one issue that I am facing. We'll continue tomorrow from the same point, and let's hope the Uttar Pradesh police resolves this as soon as possible. Bye, take care, and ciao.